Yeah, number one. I'd like to have Gabby read number one on page 85 for us. It's in your book. Page 85. That's what we're doing. This is a sample quiz. We've got 6 questions here.
If the product of two numbers is positive, then the two numbers must be negative.
What are the instructions in bold print at the top?
Show that conjecture is false by finding an counterexample.
Yes. Okay. So it says if the product of two numbers is positive, then the two numbers must be positive. Anybody think of a way of countering that? Product of two numbers is positive, and the two numbers must be positive. Go ahead, Gabby.
No, because you can have positive 3 times positive 3 equals 9, positive 9.
All right. All right. Well, usually we find out. Let's see. Product of two numbers is positive. Let's say we have. You said 3. With what? With what?
3, positive 3.
Oh, 3 and 3? All right, so you got two positive numbers here. It's positive 9. But I think Kennedy is thinking of a way he could. I mean, this is the usual. But we want a way of countering this.
Well, the book it says the two numbers must be negative, not positive.
So you're saying if you have a negative 2.
No, you're good.
Book said the book
You
said
wrote
that.
that.
Oh, I wrote it wrong?
Yeah.
All right, so the product of two numbers is positive, then the two numbers must be positive. Must be negative. Must be negative. All right, let me go back then. All right. Okay, let's restart here.
Yeah, then she's right. I'm right, so you just copy it down.
Oh, Jesus wouldn't have to do this, you know. All right. Read it again. Kennedy. But it's true. The product of two numbers is what?
Must
be
Positive, then what?
must be negative.
Yeah.
Oh, so I should have negative here.
Yeah.
All right,
Just
let
cross it
me
out.
strike that. Negative. Okay. All right. Anyone think of a way of countering that?
3 times 3 times 3 equals 9.
3 is positive.
It is positive. And then you go to the
That's pretty easy, isn't it? All right. Product of two numbers is positive, and the two numbers must be negative. So you can write that, or you can choose your own numbers. You might want to say, 4 and 5 gives you times 5, gives you 20. Whatever you can show to counter that the result is not negative. The result is positive. If you like, you can just kind of emphasize here, positive, and that would be good enough. All right. So let's take the other one. I hope I've got this one right. Tommy, read the second one for us and verify that I got it right from the book.
The sum of two numbers is always greater than the larger number.
I think that one is correct. Justin, can you think of a way of countering this?
1 plus negative 1.
Say it again.
1 plus negative 1.
All right, we got the number 1 and negative 1. And he says 1 plus negative 1. The result of that would be 0. And so 0 is certainly not bigger or larger than the larger of the two. So there you have it. That's a good counter right there. Okay? If you like, you could just put not greater than 1. All right. So that's the kind of thing you'll be looking at for your quiz coming up. Let's go ahead and do type number 3. Anthony, read for us instructions for number 3.
Points that lie on the line are called collinear.
Yeah, what are the instructions? What are we doing?
I don't know.
You don't have a book? What's up, Savannah? Read the instruction for us on number 3.
In exercises 3 and 4, write the if then form and the contrapositive forms.
So we want if then form and the contrapositive. Let me go to another color, contrast it here. Who'd like to give this a shot? If then form, Ben, you want to try? If then form for this?
If points lie in the same line, they are collinear points.
Excellent. All right, I'm going to go to another page because I see one around the room here. So let me go about a couple pages. Yeah, you're right. If points lie on the same line,
Then they're collinear.
yeah, you can go ahead and write that down. Same line, conclusion, then they are collinear. And you know that, right?
Yes.
That's the if-then form. I think they want us to get the contrapositive now. Contrapositive. And remember I told you that the contrapositive is the inverse of the converse. So let's go ahead and just do the converse, and then we do the contrapositive from that. And some of you were pretty good on your last assignment, some of you not so good. Let's do the converse here. Who'd like to try? Converse of this conditional. Nick, you want to try?
Points are collinear and they lie in the same line.
Absolutely. Points are, we just switch it around, that's all we do. And remember now, this is the switch. If points are collinear, conclusion, then they lie in the same line. All right. Okay. Teeing off from the converse, we can get the contrapositive pretty easily, because the contrapositive is the inverse or the negation of the converse. Negation of the converse. Brandon, try that one. Contrapositive. Okay, listen carefully. Somebody knows it here. Go ahead, Kennedy.
If they are not collinear, then point does not lie in the same line.
That would be a nice way of saying it. If they're not collinear, or if points are not collinear, if points are not collinear, it's just a negation. Brandon, you see it? Are not. Let me emphasize that. Not collinear.
And they don't lie in the same line.
Yes, then they don't lie on the same line. Then they don't lie on the same line. Okay. By the way, would that be a true statement?
No.
You gotta be, points are not collinear, then they don't lie on the same line?
Yes, that's true.
But yes, they've got to be collinear to lie on the same line, right? All right. They didn't ask us that, but just an extra here. Number 4, I think. I think I've got it somewhere up here. Let me go back. Is this the one?
Yeah.
Number 4. Okay. So let's read that one. Jessica, read this for us, please, and then let me see if you can give us the if-then format for that.
2x minus 8 equals 2 because x equals 5.
Yes. All right. How would you change that to if-then form?
If 2x minus 8 equals 2, then x equals 5.
Good try, but not correct. I've got to say that. See this word right here? This is kind of the forerunner. This is what is
And it's
necessary.
because x equals 5?
So it's because x equals 5. So what?
If 2x minus 8
If.
equals 2.
X is equal to 5. Because it's really hanging on this. Then what?
2x minus 8 equals 2.
Yeah, 2x minus 8 is equal to 2. Alright? So let's go step by step. Let's do the converse again. From the converse, we're going to get the contrapositive. Converse, Hunter. Hunter, wake up. Converse. Let's take another color for the converse. What's the converse of this? Hunter. Yeah. And give you this one. It's going to be if something.
If I wear shorts, then it is above 90 degrees outside.
Not this one. This one right here.
Alright. 2x minus 8 equals 2, then x equals 5.
Yes. Think you're pretty tired over there, right? Huh?
Not at all.
2x minus 8 equals 2. Then what?
X equals 5.
X equals 5. Yeah, that would be the converse now. All right, Madison.
Right.
Let's go from the converse to the contrapositive.
Alright,
All right, and let's take another color. What should I use?
Right.
Red. Let's see if I can grab a red. All right, contrapositive.
If 2x minus 8 does not equal 2, then x does not equal 5.
Correct. Let me write it. 2x minus 8 is not equal to, remember you write it like that. Strike it through. Not equal to 2. Then what?
Then x is not equal to 5.
Yeah, x is not equal to 5. Yeah, that would be our contrapositive right there. Okay? Make sure you write that down. You'll be able to watch it again. I wanted to make sure I record it, but I'm going to upload it so you can see it on, just in case you want to go take another look. All right. Let's do number 5. I think that's probably the last one we'll be able to do. Go ahead, Tommy. Read for us instruction for number 5. I don't have it before me here. Number 5.
Make a valid conclusion about the following statements. If it is above 90 degrees Fahrenheit outside, then I will wear shorts. It is 98 degrees Fahrenheit.
Okay. All right, this is kind of simple. This is assumed to be a true conditional here. I'm circling it. Assumed to be true. I'm going to use this by which law? The law of detachment to make a valid conclusion. And here's a scenario. It is, what's the temperature, 40? 98? 98 degrees. All right, so if it's 98 degrees, what conclusion can I make?
It's hot outside.
I will wear shorts, yes, yes. Because this first part is satisfied, then I can say this second part must be. So the conclusion here, I will wear shorts. Okay, pretty simple. All right. Number 6 I'm going to leave for you, so you can go ahead and look at that. Let me get this set up so I can get this recorded. Let me see how much time.